Adrian, it's a busy event here today at the AMRC. Can you tell our viewers what you're actually looking to achieve here?
What we're doing here is showing the process of cavity machining with barrel tools.
I watched your presentation, took some notes, and actually I've got some questions. And the first thing that sort of struck me is it's just about machining deep pockets, MAXX Machining.
Absolutely not. It's a process that can be used on many different shapes, many different sort of components, so from aerospace to medical.
And what I did note as well is you're machining at extreme depths of cut. So does that not affect tool wear and tool life as well?
No, it's a strange process really. With a conical barrel tool, you have that angle on the tool which enables you to get into those deep pockets. Once a tool is set for those deep pockets, is the same tool can be used over the entire part. So tool wear is really quite good.
And what about the radius of the tool as well? Because I looked at it and thought, well, might you get collision with the tool holder?
Well, this is with a conical barrel tool. Barrel tools are not new, but a conical barrel tool is, and that taper that you have on the tool means that you're really avoiding problems with the tool holder cutting the component. So large radius with traditional barrel tools would give a bigger problem with collisions, but on the taper tool, then it's no problem.
And the materials that this would apply to, because a lot of the presentation you spoke about aluminiums, but can you go beyond that?
Absolutely, yeah. It's a process where really the more difficult the material, the better the gain you get from the process. So whilst it's here is very easy to show aluminium, it's quick for demonstration, it's equally as good in titaniums or difficult materials.
And you're almost pulling the tool out, aren't you? Pulling the material out.
Yeah, especially in the corners. There's a process we're showing today where we're actually pulling the tool rather than sort of pushing the tool into material.
And you did also say that the deeper the cut, the better the surface finish. How does that work?
Well, it certainly seems to be. If you get the tool engaged in material, then it's working. It's not rubbing the material away.
And with some of the tools, they look quite lengthy. Is that not a problem with things like chatter?
No, definitely not. It's usually the tool in this case is on a 16mm shank, so there's certainly no problem with the protrusion. We can get it a lot shorter as well. It's just in this particular example, it's a very deep pocket.
Do I have to be a really clever guy and a really with a lot of knowledge of CAM to be able to operate MAXX Machining?
Actually, it's this process is one of the simplest things we can program. It's simply pick a tool, pick a face, and calculate. All the parameters are preloaded for you. It's really quite simple to use.
And does the machine tool matter?
No, this is the interesting thing. You can, in this example, although it's a Hermia behind us, the spindle isn't particularly quick, so it's just a 12,000 RPM spindle, which is pretty standard these days. It's good on a let's say a more budget machine than it is a really high-end machine.
And you mentioned in your presentation about the fact that this is going to be MAXX Machining is going to be as big as 5-axis machining in years to come. That's a bold statement.
Yeah, I think so. Yeah, but this process with conical barrel tools, it really is that the time savings you can make are really huge. So who wouldn't like 90% time saving?
It's got to be application driven though, isn't it?
Yeah, but the application is far and wide. So from aerospace to medical to mold and die. Really, even ourselves, we're still learning with the process of where it can be applied and how it can be used.
And you've got a lot of people here today. How many days is this event running for, and how are you doing? One in the morning, one in the afternoon, I believe.
Yeah, it's 2 days, for 2 days and 2 sessions either day. So it's 4 sessions over the 2 days.
Tony, you're Tier 1 members of the AMRC now, aren't you, as part of the Ceratisit Group, is that correct?
That is correct, Paul, yes. Since the start of the year, really, we became first-tier members of the AMRC. Ceratisit Group are the official name of the membership, and within that then we have Ceratisit Cutting Solutions and WNT in our Cutting Tools business unit.
So it's the WNT part today that we're talking about on the tool front. This event has been extremely well attended. This is all about MAXX Machining, productivity, and it's something new to WNT that you're offering now as part of this solution. And that's the barrel tools, correct?
It's a new range of tools. We call them circle segment milling tools, solid carbide, so it comes within the WNT catalogue. It's a brand new range of tools to support this innovation in the software change for 5-axis milling.
And what's the benefit to the user of adapting to this type of tooling?
The main benefit is time saving. So if a customer's got particular flat surfaces or certain features on aerospace parts, mould and die parts, there's up to 90% machine time saving with this new range of tools and in conjunction with the software.
I was going to say this collaboration is with Open Mind here and their Hypermill software. The two of those together are actually, or they're saying you can reduce cycle times by 90%. That's a massive saving, isn't it?
It's an absolutely massive saving, but it's true. I mean, we're doing a demo here today at the AMRC where the time saving is of that ilk, you know, up to 90%, but it's of that ilk. And we're seeing it replicated in all the work that we've done with Open Mind, that is achievable.
And there are similar tools available on the marketplace other than from WNT. But I think one of the things for me that's apparent is that you're supplying the tool holder, the tool and the work holding as a collective, aren't you? So that's quite advantageous.
Yeah, indeed. We offer the complete solution. So it's the complete solution from the holder right the way through to the cutter itself, with full technical support, a team of 40 time-served engineers out in the field supporting customers with this. All tools held ex-stock, so a customer can order 6:30 at night, guaranteed before 12 noon next day, free delivery. So it is a complete solution with a fast, our usual fast logistics solution behind it.
And I think the message is always very clear with these types of days, is to trying to get those messages to users that this sort of innovation is out there for people to adopt. You've got lots of boots on the ground, you've got lots of sales guys, so you're going to be able to find potential users probably far easier than others, aren't you?
Yeah, indeed. We've got 40 engineers out there looking after customers, UK and Ireland, and they are engineers, not salesmen. That's an important thing to say. And they will see opportunities where they can save their customer time, which is inevitably money. So they will see opportunities, they'll see certain components where this new technology is applicable. It's not for everybody, because you have to have the 5-axis milling capability and you have to have the software. But where that is apparent as an opportunity, and there's enough opportunity within their components to make the saving and make the investment, there'll be a big return on that investment. Yeah, so they'll be looking for opportunities and putting them forward to the customer to consider.
Hiya Mark, we're here today at the AMRC. What an absolutely fantastic event. I was just wondering if you could tell me what made you come today, and a little bit about York University.
Yes, certainly. So we came today because we're potentially looking at getting into 5-axis machining. We've got a couple of 3-axis machines, but really feel as though, you know, the future's 5-axis, and just the versatility of it do wonders for you know, our sort of rapid prototyping of scientific equipment, really.
I think as well for the students, I think it'd be so beneficial for them to be able to learn on a 5-axis machine.
Definitely, and I think primarily for me, we support academics and PhD students, and again the versatility and the speed with which you can prototype a part. It's just, you can't come near it in any other way.
And what do you think about the presentations that were given today and the new 5-axis technologies?
Oh, it was incredible. I think until you actually see it and you see the difference between how it was traditionally done and how it's done now, or how it potentially will be being done in the future, it's night and day. I think it's incredible.
Mark, thank you very much for your time.
All right, thank you. All right, spot.